Hello students, welcome to Tantray physics classes. And here I have come up with one more challenging problem because it is a series of problems that I am going to discuss on YouTube. And the problem is like this. You see, today I have come up with a problem which is, if you learn this problem, then you will learn a class of problems you can solve yourself. It is a representative problem, a heavy one. But if you learn it, I will show you some techniques. And if you learn it, then obviously you can solve all the problems of the field, which involves a DC source, resistors, and inductors. Not only a single inductors, maybe there are many inductors. Problem is like this. It is a DC source, and we have three resistors here, R, and 2R, and there's also an inductor L, having inductance value L. Right? We'll try to solve this problem. Then I will explain you how it can be a representative problem, how you can solve other problems very easily. Okay. The question is, what's the current through the inductor, IL? This is the question. How the current in the inductor changes with time, how it builds up. It is a growth of current in the inductor. Initially, the current in the inductor is 0. Then, if we switch on the source, the input voltage or a battery, when we connect a battery, and then the current starts building up in the inductor. That is, the current starts growing up in the inductor. The growth, it is the set of problems where the current in the inductor grows or builds up. Means initial current is 0, and finally, obviously, the current will be maximum. So we have to explain that also. So this problem is for the growth of the current in the inductor, right? But there are some properties of the inductor. Inductor has some properties because you see in the inductor, it's a coil through which when current flows, it builds up magnetic field inside, the flux. And the inductor behaves in such a way as to oppose the change in flux. So that simply means if current in the inductor initially is 0 and the current starts building up, there's a change in flux in the inductor which opposes the change in current, which opposes the current that you try to build up. So when for the growth of the current in the inductor, initial current is always 0 because there will be a back EMF. The inductor the induced EMF will be produced inside the inductor in such a way as to oppose the initial current. So initially, it's always, whenever the current tends to grow in the inductor, initial current is always 0. That you must remember. So the inductor offers infinite resistance to current when it starts building up in the inductor. जब करंट इंडक्टर में बिल्डअप होना शुरू हो जाता है तो देयर इज अ बैक ईएमएफ. ये जो इंडक्टर में फ्लक्स चेंज हो रहा है, दैट विल प्रोड्यूस अ रिवर्स करंट व्हिच विल टेंड टू डिक्रीज द करंट इनिशियली. मींस इट विल ट्राई टू कीप द इनिशियल करंट एज 0. But the battery is there, it builds up the current anyway, and there is opposition from the inductor. But the current builds up, and finally, what happens? So at t is equal to 0, current is always 0. In case of growth, in case of building up of the current. But finally, when the current achieves steady value, constant value, जब last में current constant हो जाता है, the inductor offers no reactance, no resistance. फिर inductor कोई opposition करता है नहीं, because by the time current is constant, the flux inside is constant, there is no induced EMF, so current remains constant, so there is no opposition, and this inductor then acts as a short circuit. It is as good as a wire, simple ideal wire. कोई opposition नहीं current को देता है. So current remains constant. The moment current remains constant, inside flux inside the inductor also remains constant. There is no reactance from the inductor to the current. Okay. So finally, when the current achieves steady value, the inductor offers no reactance. Then it acts like a short circuit. Ideal wire. Yeah, ideal wire बन जाता है last. So what you remember is initially, when the current starts building up in the inductor, the current in the inductor is 0. And finally, the current in the inductor is maximum. Because by that time, when the current is steady, the reactance offered by the inductor is 0. it is an ideal wire which tends to 0, because every wire has a resistance which is very, very small resistance offered by the inductor when the current is steady or constant. Okay, now I have to find this IL as a function of time. Obviously, what we have learned is that initial current is 0 and final current is maximum and constant. That is, we know two extreme cases. At t is equal to 0, current is 0. At t is tending to infinity, after a longer period of time, relatively longer period of time, current should be maximum, and by that time the inductor is just a short circuit. It is just a wire, straight wire for the circuit. Okay, let me try to solve this circuit for the IL, current in the inductor. Let me suppose current I flows from here. This current goes through the resistor R. Okay, then this current splits. It is IL from here in this part of the circuit, and remaining current is here. Okay, I minus IL. There are two equations, one for this loop, other for this loop. So what is the equation for this loop? If you apply Kirchhoff voltage law, it will be that is very simple. You can apply Kirchhoff voltage law here and Kirchhoff voltage law here. Okay, if you want to make it, but that's not even important. It's positive to negative, it is positive to negative, it's positive to negative, and current flows downwards, so it is positive point is negative point. Voltage drop. Okay, so let me apply the Kirchhoff voltage law here. Voltage rise, these are the two drops. So what should I write? First equation, E, voltage rise, is equal to voltage drops, that's IR plus I minus IL into R. Equation number first, right? And now let me apply Kirchhoff voltage law here. So voltage rise, it is voltage rise, and these are the two drops. Voltage rise is I minus IL, current through the inductor, into R is equal to, okay, voltage drop, here is the IL flowing from here, same current here. So it is 2R IL plus, what is the voltage drop across the inductor? So far as the current varies, there is induced EMF in the inductor because of the change in magnetic flux inside. So that is what's the voltage across the inductor. The voltage across the inductor is rate of change of flux inside, d phi by dt, and that is equal to L dIL by dt. If you want to know it, it is just flux is Li, differentiating both sides, d phi by dt is equal to L di by dt, and this is nothing but the voltage. So voltage in the inductor is L di by dt. Okay, it is second equation. So I will use these two equations to find the current in the inductor, IL. That's all. These two equations I have to solve, and what I will do, I want to get rid of this I, and then I will substitute this I here. That is all. तो यहाँ से मुझे क्या I मिलेगा? What will I के लिए मुझे क्या मिलेगा? चलो ठीक है, मैं पहले यहाँ I निकालता हूँ, फिर इसमें डालता हूँ. चलिए ठीक है. What is I? So it is IR. It will be 2IR. Okay, let me solve it for you. It will be E equal to IR plus IR minus ILR. Okay, so get it here. This E plus ILR is equal to 2IR. What is I? That is E plus ILR divided by 2R. This is I. So this I will put here. Put this I here in this equation. Okay. ये I को मैंने यहां से लाया और इसी I को मैं यहां डालूंगा, तो फिर equation I will be getting in IL. So that is good. That will be better. अब मैं सिर्फ इस I को यहां डालना है. So what is this I? E plus ILR by 2R minus IL into this R is equal to R IL plus L times DIL by dt. Okay, now let me make some simplifications. E plus ILR minus 2ILR by 2R into this R gets cancelled is equal to RIL plus L times DIL by DT. So R gets cancelled, 2 multiply here on the right side, so it is E, ये ILR और 2ILR minus ILR होगा is equal to 4 हो जाएगा RIL plus यहाँ 2 multiply होगा, that is 2L DIL by DT. I am solving for IL. Don't forget that. I am solving for IL. I have to get IL somehow. That's the current through the inductor. I would like to, yes, you already know the initial current should be 0 and final current should be maximum. That's all. But what is the current variation as a function of time? There it must be an equation. The equation that I will get, if I put t is equal to 0 in that equation, I must get the current IL 0. If I put t tending to infinity in that equation which I am going to get, I should be getting that current maximum. What is that maximum? That we will come to know. कितना maximum value होगा? Okay. तो ये equation मैं यहां रखता हूं, तो क्या होगा? चलो इसको इसी में रहने दीजिए और इसको यहां लाइए. तो it will be 2L times DIL by DT is equal to, okay, ये यहां जाएगा, it will be E minus यहां जाएगा 5RIL. That is the equation here. Okay, so why not to do one thing? DIL by DT is equal to E minus 5RIL by 2L. That's right. So why not to do one thing? Separation of variables. L को यहां लाइए और बाकी चीजों को वहां ले जाइए. That's called what we call a separation of variables. तो separation of variables हम जब करते हैं तभी तो equation solve होगा. It is the technique through which we can solve differential equations. So DIL by ये जो न्यूमरेटर में है इसको लाइए यहाँ डिनोमिनेटर में, E minus 5RIL is equal to DT by 2L. Okay? अब जाकर हम इंटीग्रेट करेंगे. What is IL initially? 0. What is IL after some time? Okay, let me say IL after some time. Not infinite time, after instantaneous time. So what should I do here? Time 0 to any time. So it is IL नीचे और ऊपर इसका डिफरेंशिएशन बैठा है, तो इट इज log of the denominator, ln E minus 5RIL डिवाइड बाय इस नीचे वाले का डिफरेंशिएशन यहां लिखना पड़ता है डिनोमिनेटर में, इसका 0 और इसका होगा minus 5R is equal to 1 by 2L बाहर आएगा और dt का इंटीग्रेशन t. अच्छा, we are closing up now. Possibly we will get the answer for IL. 0 to IL यहां पर. तो it is ln of E minus 5RIL is equal to, ये यहां जाएगा, that is minus 5R by 2L and T. Okay, मगर it is 0 to IL. तो पहले ये वैल्यू देना पड़ेगा, फिर माइनस करके ये वैल्यू देना पड़ेगा. That is ln of E minus 5RIL minus ln of, तो 0 यहां रखने से ln E हो जाएगा, minus 5R by 2LT. ओके, चलिए, तो इट विल बी ln ऑफ दिस बाय दिस, दैट इज जब ये डिवाइड करेंगे दिस और ई को यहां डिवाइड रखोगे तो ई को डिवाइड करने से यहां 1 minus 5RIL by E. This is applied voltage, DC voltage, is equal to minus 5R by 2LT. So what is this? तो लॉ को वहां जाकर के एंटी लॉ करना पड़ेगा. There is 1 minus 5RIL by E e raised power, जब log को वहां shift करते हैं to the other side, it becomes anti-log, right? And that we know it is e raised power 5r by 2lt. So what about this IL? What about that? कैसे करेंगे आप? तो इसको यहां और इसको वहां ले जाइए. It will be 1 minus e raised power minus 5r by 2lt is equal to, okay, 5r by EIL. Is that right? Okay. Now what is IL? IL is equal to this E by 5r, this way, 1 minus e raised power minus 5r by 2lt. That is the answer for the current build up in the inductor. This is the expression for the current. So let me check out the equation by using extreme conditions like t is equal to 0 and t tends to infinity. So I have already told you, initially when the current starts building up in the inductor shows high reactance to the current and it will not allow to current to pass initially. I mean at t is equal to 0, current will be 0, right? T is equal to 0, put it here, e raised to power 0, that is 1. 1 minus 1, 0. So IL is equal to 0. That is what we know. And that is what is our initial physics, which we have put in. T tends to infinity. It is e raised power minus infinity, that will become 0. So this part goes and the current in through the inductor is E by 5R. That is the maximum current and that is the final constant current. Right? And by that time, the inductance does not show any reactance. It allows the current to pass through. It is a short circuit. Right? Okay. But now, all this is done is a very good circuit. I will show the same thing for a simple circuit. And then I will show you how to do it in a minute. All this derivation you don't need to do. You can do all such questions in a minute. So that is what I want to do with you. Let me go to that concept. How to solve such a problem or how to imagine the answer to such a problem instantly or to solve such a problem within a few minutes, right? Okay. Let me do it in the next phase. Okay, this is a simple circuit which contains resistance and inductor in series, a very simple circuit. This one. And here also, the current starts building up in the inductor. Here also, we have initial current to be 0. Because initially, when you switch on this the source to the circuit, the inductor will show a reactance and it will not allow the current to flow. But finally, the battery will force the current and finally the current will remain constant and at that time current will be maximum after some time. But initially current is 0 and finally the current is maximum, right? So here it will be a simple equation. If you want to write an equation for this is plus minus because current flows from higher potential to lower potential, it is plus to minus because current goes forward. If you want to write the voltage rise here, that's E, voltage drop, that is IL, R, and is again drop, that is L DIL by dt. Simple equation. Earlier जो हमने circuit किया उसमें दो equations थे. That was more complicated circuit. It is simpler circuit. और यहाँ भी आप IL निकाल सकते हैं. कुछ भी नहीं करना है, इसको यहाँ shift करके separation of variables करके इसमें कोई time नहीं लगेगा because the earlier circuit was a little more complicated than this. But I will write down IL. I will imagine that IL should be, because I know initially the current through the inductor must be 0 and finally it's maximum. So within those two parameters, within those two extreme conditions, I can just write down the equation. That is I max, maximum current, into 1 minus e raised to power minus R T by L. This is the equation for this. For any other circuit which contains so many resistors, which contains so many inductors, maybe, possibly, 2 inductors, 3 inductors, let it be. And we have to find the current through any inductor. What should I write? द जनरल इक्वेशन इज ओके आई मैक्स तो होना ही चाहिए इन दैट केस where there are too many resistors, where there are too many inductors. 1 तो होना ही चाहिए e raised power माइनस, ये r जो है फिर ये r नहीं रहेगा, फिर ये r वहां तो बहुत सारे रेजिस्टर्स है, 2-3 रजिस्टर हो सकते हैं, 4 रजिस्टर हो सकते हैं, लेकिन यहां तो एक ही रजिस्टर है, इसलिए मैं यहां लिखूंगा r, ये वाला r, मगर इक्विवेलेंट वहां निकालना पड़ेगा, ये कितना रेजिस्टेंस वहां मतलब मैटर करेगा, बाय L be equivalent ही into T. So in the given circuit, what I had to find I max, R equivalent and L equivalent. Once I know this and this, I will write this answer directly for any circuit that I have. So what is R equivalent here? That's only R. What is L equivalent here? That's only L. What is I max? Here in this case, I max should be, I will write that, I max should be when it becomes a short circuit. Finally it becomes a short, it becomes just a wire, so the current at that time is E by R. So finally when this becomes a short, current is maximum, that is E by R, 1 minus e raised to power R by LT. Okay, this is a general equation. Now let me go to the circuit again, the circuit that I had. Let me go to that circuit again. Let me see how can I solve it now within no time. So I again go to this circuit and let me see how to find the answer directly to any such complex circuit which contains many resistors, many inductors, maybe even many sources. It will work. So what is the equation that I have for general circuits, for any circuit? Although I started with a simple circuit that is containing only one resistor and one inductor. So that was IL is equal to I max 1 minus e raised to power minus R what? RT by L. But it is R equivalent, it is L equivalent, right? Sorry. First of all, in this case, what is L equivalent? What is L equivalent in this circuit? What is L equivalent? There's only one L, so L equivalent is L. What is R equivalent? How many R's are there? R, and R. How to find R equivalent? Tell me how to find R equivalent. Now I will give you the technique how to find R equivalent. What we need to write here, R equivalent. R equivalent will be obtained by short circuiting all the sources, all the voltage sources. अगर एक है तो एक को शॉर्ट कर लो, अगर 2-3 सोर्स है तो उन सबको शॉर्ट करना पड़ेगा और फिर आपको R equivalent निकालना पड़ेगा. So to find R equivalent, short which one? Short the voltage sources. जो voltage source आपके पास है उनको शॉर्ट कर दो. तो देखो मैं क्या करता हूँ, हैव ए लुक. ये वोल्टेज सोर्स है, इसको मैंने शॉर्ट कर दिया. अगर 2-3 और भी सोर्स होते तो उनको भी शॉर्ट कर लेना था. तो अब ये रेजिस्टेंस क्या आपको मिलेंगे? दिस आर एंड दिस आर, दे आर इन पैरेलल्स, क्योंकि ये तो यहाँ आ जाएगा. This and this are in parallels. If you understand this and this are parallels, because potential difference between this and this is the same between this and this, because this point and this point are the same potential. When potential difference across the resistors is the same, they are said to be contained in parallels. तो ये R और R है, ये R by 2 हो जाएगा, और ये R by 2 इस 2R के साथ सीरीज में. पहले इनको कंबाइन करो, R और R, that is R by 2, और फिर 2R के साथ सीरीज में, वो हो जाएगा R by 2 plus 2R is equal to 5R by 2. तो आपको R equivalent मिल गया. So simple. R and R, they are in parallels, R by 2, and with this 2R in series, so that is 5R by 2 is the resistance. अब हमें सिर्फ I max, see what is I max? इसको मैं कैसे निकालूंगा I max को? तो I max को निकालने के लिए फिर से आप वोल्टेज सोर्स कनेक्ट कर लो. और ये वोल्टेज सोर्स जो है, अब फाइनली आर मैक्स जो करंट मैक्सिमम आ जाता है ये इंडक्टर के थ्रू, उस सूरत में ये इंडक्टर जो है ये शॉर्ट हो जाता है ऐसे, और आपको IL निकालना है क्योंकि फाइनली द इंडक्टर बिकम्स ए शॉर्ट बिकॉज इट ऑफर्स नो रेजिस्टेंस नो रिएक्टेंस, सो इट बिकम्स ए शॉर्ट। तो आई हैव टू फाइंड IL, तो क्या हो जाएगा IL, कितना निकलेगा मुझे, तो ये सर्किट एनालिसिस करना पड़ेगा। लेकिन आई विल शो यू एनालिसिस इन ए शॉर्ट वे, आई विल नॉट अलो दीज टू इक्वेशंस, आई विल नॉट राइट टू इक्वेशंस, बट आई विल डू, इसको ग्राउंड कर दो। सर्किट में कोई भी पॉइंट आप ग्राउंड कर सकते हैं। अगर ये जीरो है तो इस पोटेंशियल डिफरेंस E है, तो ये E यहां पर है, सो दैट पोटेंशियल डिफरेंस इज दिस वोल्टेज ऑफ द बैटरी। तो यहां वोल्टेज समझो V है, ठीक, यहां वोल्टेज, अगर मुझे ये वोल्टेज मिलता है तो आई विल फाइंड करंट थ्रू हियर, I max, IL, that is I max. तो I should write some equations here, two equations, कुछ ज्यादा नहीं। तो E minus V, potential difference divided by R, that is current like this, that becomes current through here, that is V minus 0 by R plus V minus 0, यहाँ 0 potential है, by 2R, ठीक। ये किरचॉफ करंट लॉ है, current through this is called this plus this, current through this is E minus V by R, through this is V by R, through this is V minus 0 by 2R, तो R gets cancelled, 2 को multiply करो, it is 2E minus 2V is equal to 2V plus V, ये वहां जाएगा तो 4V हो जाएगा, सो नहीं 4 plus 5V होगा is equal to 2E, तो V is equal to what, 2E by 5, तो यहां मुझे वोल्टेज मिल गया 2E by 5। अब आप मुझे बताइए व्हाट इज करंट फ्रॉम हियर, 2E by 5 minus 0 by 2R, current is in this branch, potential difference by resistance, so what is I max, that is 2E by 5 minus 0 potential here divided by 2R, that is E, 2 cancels, E by 5R, I max भी मुझे मिला। तो what should now I write for the general this equation, okay, that is IL is equal to, what is I max, E by 5R into 1 minus E raised to power, what is R equivalent, minus R equivalent 5R by, okay, I should write it somewhere, you know this, now you know this also, you know this also, let me remember it, and I want to write it somewhere here, okay, I is equal to I max 1 minus E raised to power R equivalent by L equivalent T, so it is I equal to, what is I max, E by 5R into 1 minus E raised to power, what is R equivalent, 5R by 2, what is L equivalent, L equivalent was L, only L into T, that is I equal to E by 5R 1 minus E raised to power 5R by 2L T, आंसर। सो जो इनिशियली हमने डेरिवेशन किया, पूरा इक्वेशंस लिखा, दिस ब्रांच इक्वेशंस लिख करके हमने फिर सॉल्व करके लास्ट में आपको आंसर बताया, तो आंसर वाज दिस। तो हमें सिर्फ ये R इक्विवेलेंट निकालना है, L इक्विवेलेंट और I मैक्स, उसके लिए मैंने आपको टेक्निक दिया है। सो दिस वाज ए कॉम्प्लेक्स प्रॉब्लम, this advanced level, and for those who want to go for the Olympiad also, this problem is good for them, and this will help you to solve a class of problems. If you do it many a times, and definitely and certainly you will know, you will be dealing very easy with these problems where you have inductors, resistors, and DC sources. But don't forget that it was current building up, growing up, growth of current in the inductor. There are some cases where current decays in the inductor. We have a different rule. Because when the current grows up in the inductor, the initial current is 0, final is maximum. When current starts decaying in the inductor, that I will give you discuss in the next challenging problem. And here I ask you again to watch my lectures on the YouTube and subscribe to my channel, Tantray Sir Physics Class. Also, if you like to download the application Tantray Sir Physics Class from Google Store, you can do that, and there are questions which you can solve for yourself. Thank you.